Today we are going to learn how to write and solve algebraic equations using verbal models that represent real-world problems. In order to do that, we need to get some vocabulary down. So our first vocabulary word is verbal model. A verbal model uses words to describe ideas and math symbols to relate the words. In other words, think of how Miss Bernowski might write something in math. That's what a verbal model is versus how a mathematician would do it. So I'm going to go ahead and write down the definition, and you can too. Alright, so here is an example. Two increased by a number that might be how Miss Bernowski would write something. She would use all words. A mathematician would write that as 2 plus x. Since the number is unknown, we use a variable. So the top is how Miss Bernowski might write it, and the bottom is how a mathematician might write it. So this right here would be the verbal model, the top line. We have talked about expressions and equations before. An expression consists of numbers, variables, and operations. It has no equal sign. An equation is a mathematical sentence that sets two expressions equal, and it has an equal sign. So go ahead and write those definitions down, and I will too. So I have written the definition for expression, and I have written the definition for equation. And then I'm going to go ahead and give some examples. The definition for expression consists of numbers, variables, and operations. So an example might be 15 plus y. So you have a number, you have a variable, and you have an operation. The operation is the plus sign. Another example might be 2s minus 10. So you have numbers, variables, and operations. A mathematical sentence, or an equation is a mathematical sentence that sets two expressions equal. So an example of that might be x plus 7 equals 30. So you have two expressions separated by the equal sign, and again it contains numbers, variables, and operations. Okay, we are going to define what I call trigger words, and by trigger words, when we hear these or when somebody says these words, we think a certain operation. So our operations that we're going to talk about are adding, subtracting, multiplication, division, and equal. So when we hear increase, we should think add. When we hear more, 5 more than 2, we think add. Sum, of course, means add. Plus means add. Total or added to. So those are all words. When you see them in a sentence or you hear somebody say them, you should think, oh, I'm going to add. Then same thing with subtraction. Some words that mean subtract, decrease, less than or less, 5 less than 2, difference, minus, fewer than, or subtracted from. So when you see or hear those words, you should think to yourself, oh, I'm going to subtract. Okay, then for multiplication, double. If you double something, you're multiplying by 2. Product means to multiply. Times of means to multiply. That was on our target check that we did on the one-step equations, where it was 1/4 of the total people equals 39. When you see of, that often means to multiply. And then twice means to multiply. So those are some words that when you see or hear or read them, you should think, oh, I'm going to multiply. Let's see. Some words that mean to divide are quotient, separate into equal parts, which is really what you're doing when you divide. And then equals, when you hear the word is, that means you're going to set that first part of the sentence to something else. You're going to set it equal to something else. So these are all words that when you hear, see, or read them, you should think those different operations. So our first example, we are going to translate the following verbal expressions or equations. So we're going to take how Ms. Bernowski would write it, and we're going to translate it into how a mathematician would write it. So our first one is a number increased by 3. So a number, when we don't know something, we can use a variable, and I don't care what variable you use. I usually use X, but if you want to use the first initial of your first name, that is fine. Then increased is add, and we're increasing by 3. Okay, on the second one, I have that one starred. Be careful with that one, because it's written, we want to just write 9 minus X, but when you think about it, 9 less than 10 is 1. 9 less than 15 is 6. Okay, and so really what we're doing is we're taking the number minus 9. Okay, so be careful with that one. That one is starred, and it is starred for a reason. Then one more, so one more, which would be plus 3 times a number, 3 times X. I'm looking for different colors. Okay, so then 5 decreased by the quotient of a number and 2. I'm going to do that one down here. So 5 decreased by a number, or by the quotient of a number and 2. There you go, that's what it is. 5 minus X divided by 2. Okay, so that's how you would do number 3, or number 4, I'm sorry. Then the next one is the product. So product means to multiply of 2/3 and a number. So 2/3 times a number is means equal 15. And then my last one is the difference of a number and 6. So I'll use an N for that one. Equals -2. All right, so and I have, let's see, this should be 6. I don't know what I was thinking there. So a lot of times, like, we use operation symbols and numbers and variables because it is a lot easier for our brain to think about than the way Ms. Bernowski would write it. All right, the next example says writing a verbal model for expressions and equations. We're going to go backwards. And I usually just take the easy way out. It does not have to be fancy to be right. So 9 plus N would be 9 plus a number. X minus 26 would be a number minus 26, and I get lazy. I don't always write out my numbers because I get lazy. Okay, then the next one, you might put a little star by this one as well. I'll do this one in red. So how we say that and write that is 2 times the quantity of a number plus, oh, I guess I should write the word, plus 5. Okay, so that one's kind of a special thing. We talked about that when we did distributive property, but I don't think I ever had you write down the proper way to say that. Okay, then number 4. I'm going to do number 4 over here. A number divided by 18 is 32. Okay, so again, I didn't use the fancy word quotient or anything like that. And a lot of times I think it's easier for non-mathematicians to be able to figure out what you're trying to say if you just use simple words. Okay, then the last one is 15 minus 3 times the number is 30. Okay, so again, I didn't get real fancy with that. I kept it pretty simple. All right, let's look at our next example. It says translate the verbal model and solve for the variable. So I have 9 plus a number is 15. I'm going to solve that using the algebraic process. To undo positive 9, I have a negative 9. That goes away. On my brother's side, I'm left with n, and then 15 minus 9 is 6. Okay, then let's look at example B. 1/4 of a number, so that's multiply. 1/4 of a number increased by 2 is 10. Subtract 2 from both sides. I'm left with 1/4 x equals 8. Then to undo division, I'm going to multiply. X equals 32. Okay, so let's look at that last example. Writing and solving an equation. The cost of a fish dinner is 3 times the cost of a chef's salad. The fish dinner costs $21. Find the cost of the chef's salad. Okay, so sometimes when I am solving word problems, I kind of write them out in words and then I plug in the numbers that I know. So it says a fish dinner is 3 times the cost of a chef's salad. Okay, and I need to find how much the chef's salad costs. Well, it tells me the fish dinner is $21. So I have 21 equals 3 times the chef's salad. So I'm going to divide both sides by 3 to undo multiplication. I divide. That goes away. I'm left with S. 21 divided by 3 is 7. So the chef's salad is $7. And then I can check that. So it says that the cost of a fish dinner is 3 times the cost of a chef's salad. 3 times 7 is 21, which is how much the fish dinner costs. So that is right. That is my final answer. If you have questions about anything that we've done, please come see me in the morning.